All right, welcome to describing quantitative data, part one. Let's just jump right into it, okay? So first, what is a statistic? A statistic is a set of procedures and rules for describing and reducing large amounts of data into manageable proportions to draw meaningful conclusions. And there are two different kinds of stats, two meaningful branches. There's descriptive stats and inferential stats. So descriptive statistics are numbers that summarize data, right? We're looking at like averages, ranges, frequency counts. And then we're looking at inferential statistics, which is using data to make generalization and prediction about a larger population and other future stuff. So kind of putting numbers together to summarize a data set. That is descriptive stats, and then inferential stats is using numbers to make generalizations to predict stuff. Descriptive stats is things like, Lotto 649. 45 is the most frequently drawn number in the Olympics. The age range for Paris 2024 athletes was 54 years old, yada, 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 right? Summarizing numbers in a data set, averages, ranges, frequencies, whatever. When it comes to descriptive data summaries, we typically want to measure, we want to capture the typical score or the center of the data, the thing that is around the middle, and we do that with measures of central tendency. So, again, what's a stat? We got two main branches: descriptive stats. That's numbers that summarize data in averages, ranges, frequencies, and inferential stats, which is using data to make greater generalizations and predictions of things. When it comes to descriptive stats, we want to capture the typical score or the center of the data, and this is done using measures of central tendency. Measures of central tendency are referring to the mean, the median, and the mode. They are a typical value in a collection of numbers or data set, and we'll go through them. We have a kind of like a quick summary here, and then we have elaborate, expansive terminology. So the mean is the average. It is the sum of all numbers divided by the number of numbers. So you add all of them up, you add all the numbers up, you divide by the number of the numbers, and that lets you find the average. So it uses every data point, right? Every number. The advantage is that it's the most common use of measure of central tendency. The issue is that it is easily distorted by outliers, and we'll get into more of these later. The median is the middle score in ordered data. So you have a data set, you order your values, and you take the middle one. If it's even, you take the two middles and you average them out. The median is resistant to outliers, unlike the mean, so it's good for skewed data. So it can represent the typical center better with skewed data. The issue is that it ignores extremes. That's a disadvantage. Sometimes it can be good, but it can also be bad. Sometimes we want that for the data set. And the mode, finally, again, mean is the average, median is the middle in the ordered data. The mode is the most frequent value in the data set. It is the most common value. This can be unimodal, bimodal, or multimodal. We'll talk about that. The advantage is that it works with all data sets. It's not affected by outliers. The disadvantage is that it may not reflect the whole data set if values vary. We'll look into all of these. But again, the mean is best for symmetrical data with no extreme outliers. The median is best for skewed data, things like house prices, for example. And the mode is best for categorical or the most common value. Again, with mean being the average, median being the middle, and the mode being the most frequent data. We'll look at this. Let me just grab a water bottle. Skip like 20 seconds ahead. Okay. So, the mean. Again, the mean is the arithmetic average. It is the sum of all scores divided by the number of scores. When it comes to the notation of mean, we have two. We have the population mean and we have the sample mean. The population mean is used for measuring the people we're interested in more broadly. The sample is used with the data we actually have. And we have two separate formulas. So population mean, if you just look at the screen, when it comes to representing that in formula, we have what is a mu sign. That is referring to the population. The population mean is equal to the sigma notation here. It's the adding of all data entries here. That is what that is referring to, over the number number of values in the data set. In the sample mean, we have an X bar. If you look at the screen, the X bar just represents the sample. Again, so the mu is the population, the X bar is the sample. It is equal to, again, the sigma notation here, which is all the data entries, again, over the number of values in the data set. Again, the advantages here: most widely used and commonly used statistic. It uses every single data point. The disadvantage is that it's sensitive to outliers or extreme values. It may misrepresent the typical experience, and knowledge about individual cases is typically lost when we average out score. Okay. Median. The median is the middle score. So how do we calculate that? Right, we order or we rank the data. The position of the median is equal to the number of entries plus 1 divided by 2. So the formula would be position equals, in brackets, n plus 1, close bracket, divided by 2, or n plus 1 over 2. It is again just the middle number. If n is odd, right, the median is in the middle. If n is even, the median is the mean of the two middle data entry scores. So again, kind of like what we were saying before, if it's odd, you just pick the middle one. If after you rank it, the median is even, if the number is even in the middle, you just average out the two scores. The advantages of the median is it's not influenced by extreme scores. Again, the median is not influenced by extreme scores, unlike the mean. It provides a reasonable estimate of what most people mean by the average or the center of distribution, and it's really good for skewed data like house prices, for example. The disadvantage is that it ignores extremes, which can be important, and it's not appropriate for all data types. For example, we can't really use it for categorical data. And finally, we have the mode. The mode is the most frequent value in the data set. If no entry is repeated, the data just has no mode. If two entries occur within the same greatest frequency, each entry is a mode, meaning we're bimodal. If 4 entries occur, or like 3 within the same greatest frequency, each entry is a mode as well. That means we're multimodal. If there is just, 1, we are unimodal. So, I don't know if that applies here, actually. Ignore that. Anywho, so we have an example here, actually, if you just like to look at the screen. This is interesting. So here, if you look at the frequency, it would look like, if you just looked at this and you just looked at the mode, it would look like there is no mode. But the mode is 56. Again, here, liberals occurred with the greatest frequency in this little political party frequency thing. Conservatives had 34 frequency, NDP had 21, Green Party had 9. Liberals had the greatest frequency, 56 supporters, the largest group. So again, just the most frequent value advantage. It works with all data sets, nominal, ordinal, interval, ratio. It's not affected by outliers, and it's the most frequently obtained score. The disadvantage is that it might not represent all the data, and if the distribution is multimodal, interpretation can be tricky, and it ignores extreme values. Mean versus median, right? Let's focus on this a little bit more. So we've kind of been using this house average affordability thing. Yeah. So the issue we're looking at right here is how much an outlier can really set this off in the mean versus the median. The mean is best when data are symmetric, when data is symmetric, and without extreme outliers. Again, it can be easily distorted by by skewed data. The median, however, is better for skewed distribution. So when it comes to house prices, when it comes to affordability, um, you'd want to present people with the median here because the mean is so greatly distorted by the one outlier that it throws everything off. Affordability looks whack. But with the median, balances out a little bit more, right? If we remember, the median is just scoring the data when it's ordered, um, which would naturally be averaged out to a degree. So yeah, it would be better for us in our case here. Misuse of statistics, right? Um, it's really all a case by case basis. You need to decide what to use and when to give people a better and more accurate idea. Everyday language, for example, always it often equates average with typical, but mean, which is the average, doesn't always mean typical in many cases, especially you know, when outliers are present, you don't want to use the mean. It's not the typical use. Always, the idea is that you should always just be considering what measurement best represents the data, and if you don't do that, you could be misusing statistics and painting a false narrative. Uh, yeah. Um, just some practice of linking central tendency to measurement levels. So when it comes to nominal data, remember we had discussed this. Mode is appropriate, right? For example, it's nominal again. It's categorical in no order. So if we were looking at the most popular ice cream flavor, we would just want to look at the mode, right? Whatever's the most frequent. Uh, Again, nominal data is no order. It's categorical. You can't take an average of it, so it can't be mean. If it can't be ordered and numbered, it can't be median, right? Ordinal data is ranked. Why? Or median is best for ordinal data, which is ranked. Why? Um, well, we'll see. So median and mode can both be used when it comes to ordinal data. Remember, again, that's categorical, but it can be ranked and ordered. Median and mode can both be used, but median could find the response in the middle as far as the rank goes. Um, Mode might not necessarily be applicable. Mean can't exist, period, because we don't know if the categories or options are equally spaced between each other. Um, yeah, it's kind of just a whole thing. Yeah, you can't average anything. Yeah. So again, ordinal data you'd want to use median. Nominal data you'd want to use mode. Let's look a little bit further. Let's look at quantitative differences in measurement levels. So like not interval or ratio, but like when it comes to discrete quantitative data, for example, mean, median, or mode can be used depending on the context, right? Like the number of children in families. You could potentially average that out. You could find the most most children had families. Uh, yeah, you could number the children and rank them in the middle. It kind of just depends on the context. When it comes to continuous quantitative data, mean is usually the most informative, right? Continuous, right? It's on that scale. Finding the average of what you're looking for, whether it's like height, weight, test scores, would probably be best. So the key takeaways: um, statistics condense data into digestible insights. Descriptive statistics summarize. Inferential statistics generalize. Measures central tendency, right? Mean is the arithmetic average, best with balanced data. Median is the middle value, best with skewed or outlier heavy data. Mode is the most frequent, which is best with nominal or categorical data. No single measure is always superior. Context determines the best choice, and critical thinking is needed to avoid misuse of averaging, for example. Um, Yeah. Oh, yeah. Um, yeah, this was just an example that we had on the practice test. I just made a note that the zeros count. I don't know if it's going to be how it is on the real test, but in all the practice questions, we counted the zero and we didn't discount zeros. So when we were, averaging, when we were ordering and then finding something in the middle, when we were considering frequency, zeros counted. So take that as you will. Yeah. Anywho, we'll see you guys in describing quantitative data part 2.